Okay, so we're going to talk about color modes and memory, especially here in processing. So these are different color modes. RGB here is one. It's the red, green, and blue. Very common. Um, those in the graphic design department who deal with printing, CMYK is a traditional output with ink. Lab is another common color mode. And finally, HSB as well. The HSB is the hue, saturation, brightness. There's a lot of people that use that within processing. But for us in this class, RGB is the default mode, and that's the one that we're going to be using. Now, RGB is an additive color process, meaning when you have equal parts of each color channel, you get white light. So when you mix red and blue together, we get magenta. When we have equal parts of green and red, we get yellow, and blue and green mixed together becomes cyan. And then all of them together in those equal proportions gets the white light there you can see in the middle. Now, when we deal with color in processing, we have a function, let's say called fill, that we're going to use to color different objects. And in RGB mode, it takes 3 parameters, and we give values between 0 and 255. Now, where do those numbers come from? They come from the sort of basic memory structure of computers. If you've ever heard computers are ones and zeros, in a sense it's true. So it's a binary system that we use for memory. So binary being 2, we can have the sort of either or proposition. So a bit is the smallest level of memory, and a bit can be a 0 or a 1. And we'll see this a lot in programming where we get these either or distinctions. So we're going to ask if something is true or false. Is it yes or no? Is it on or off? Is it black or white? So 1 bit is the smallest. It can be a 0 or a 1. 2 bits is called a crumb. 4 bits is called a nibble. And then 8 bits is the whole byte. So each one of these sort of slots, so we have 8 bits here, each one of those, one strung together can create a bunch of different number combinations. So you have a 1 slot, a 2, 4, you can see how this doubles, 8, 16, 32, 64, 128. So these are common numbers that you see in computing a lot. So add all these numbers together is how we're able to get the 256. Okay? So there's between 0, which is all of them off, to all of them being on would be 256. So we can represent different numbers this way. Okay. So if we look at a graphic, here's a 1 bit, 8 colors, and as we add more and more bits to each of the color channels, we start getting these smoother and smoother gradations to the point where with an 8 bit, meaning that there's uh, 8 bits for each color channel, mixing those all together, there's a possibility of 16 million, almost 17 million different colors that you can get from it. So quite a wide variety. Okay, so this is why raster graphics are called maybe true color, true tone with that. So here's just a graph it shows from 0 being pure black to 255 pure white, and all of the different steps in between. So all the different gray values that can be represented in a digital image. And so we're going to do these for all of the different color channels, and that's how we're going to make color. Okay, so this gives you another little showcase into how this works. A 1-bit image being black or white. We have the 2 choices within that. A 2-bit image, you can have a 0, 0, which would be pure black, 1, 1, pure white, and then a 0, 1 or a 1, 0 combination. So we get 4 different combinations possible with that, and that's how we start introducing these gray tones. And the more tones that you're able to introduce to it, the more sort of the gradient becomes smoother and smoother. The variation between them becomes more and more subtle, and so we get these very nice gradations between them.